Okay, decision control structures. So when we talk about control structures, there's it's basically just terminology. You probably won't encounter this much as a programmer. It's just what we call these things. There's three primary control structures that we talk about in programming. First is sequence. You learn that instructions get executed in the order they appear from top to bottom, right? That's a sequence. And all of the programs that we've been writing up to this point, that's been kind of the object, is to reinforce the fact that one instruction follows another, and that makes up a basic program. So that's sequence. The second one is selection, which we'll be talking about tonight, also known as decision, also known as conditionals, just different terms for the idea that we want to reach a point in our program where we make a decision whether we execute these instructions next, or do nothing, or some different instructions. So we're going to take multiple paths through our code with this control structure. And the third one, which is coming up probably in a couple of weeks, is repetition. And so once you've mastered the ability to solve problems using sequence, selection, and repetition, there's a few other topics, but you're well on your way towards being successful at whatever programming language you try to do next. That's my goal, is to get those three main things down. You've got a whole bunch of other topics like creating functions, little reusable bits of code that you can call instead of copying and pasting lines of code all over your program. That's just not the way we do things. So getting the subroutines and functions, procedures, things like that is another interesting topic. And then it's like, what kind of cool things can we do with our knowledge then? We can talk about reading and writing the files, communicating with other services over the network, and transmitting stuff and receiving stuff. There's all kinds of things that you can branch out into. Then you get into web development, and it just gets cooler from there. But for this class, we'll just stop at those three basic control structures and try to reinforce those and give you guys a good basis for continuing from here. The book's got pretty good stuff in there if you're following along in the book. But as you're reading along with that, I want to make sure I go over and hit the high points for you. So the basic decision control structure is if-then. We're also going to talk, we've talked in the past about expressions, but when we're talking about the decision control structures, we zoom in and focus on the Boolean ones, the ones that return true or false. And relational operators are what we use, greater than, less than, equal to. Those are the relational operators that we'll talk about. And then there's a whole bunch of different variations of how we can, the forms that you'll see these conditionals take. And so we'll talk about those. And then a couple of other freebies that I'll throw in along the way. And then I want to make sure that we talk about how to flowchart these things. So when you guys are making your flowcharts, a Flowgorithm or wherever, that you can use the right kind of boxes and tie everything together in the right order. Okay. So if-then is also called a selection. We're going to select which path we take through our code. And it is what it means. You're going to make a choice. You're either going to go down this path, this set of instructions, or this other path. The keywords in Python that we focus on are if, else if, which they leave out the S and the E, but it's else if, and then else. So those are the three main keywords we'll be putting together in various combinations and orders. So you'll have the if statement. You'll have some kind of a conditional expression, a true, false, Boolean expression, and then you'll have a block of statements that follow it. And in Python, the way they group together the instructions that you're going to execute only if that conditional is met is you indent by a couple of spaces. So everything that's indented the same, indentation is significant in Python. So if you push your code over, that means all of those statements that are indented are grouped underneath that if statement. That's how it works in Python. Other languages, it works differently. C++, C#, Java, they all use the little curly braces. You know, you put an open curly brace and a closed curly brace around the block of instructions, and those are grouped together. But in Python, we do it with the indentation. Yeah, and then, you know, if you have indented statements, they're only going to get executed if we want them to be. So let's just consider this really simple example. This is along the lines of the kind of programs we've been creating up to this point. You know, this is the pseudocode, obviously. Get a score from the user. Okay, they enter 85. Get the total points possible. Say it's 100. We calculate the percentage, 85 divided by 100, and we output the score, the total points, and the percentage. If I gave you that assignment, you guys have knocked that out of the park, just like you've been doing all the other ones. But what if we add a requirement? What if we say, when you output the score and the total points and the percentage, if the person scored an A, then we want to say, you know, print a message that says, congratulations, you did great, or something. Okay. Well, we don't want to do that if they didn't get an A. We do want to do that if they did get an A. So that we're going to do some kind of a conditional logic here. So we're going to use the if keyword. And this, we'll get to this in a few slides. I wanted to point this out. This is the simplest form of an if statement. You have a null else. So we're going to do something if the if statement is true. We're not going to do anything if the if statement is false. That's the simplest form. But as you might imagine, in a few slides, we're going to be starting talking about do these statements if it's true, else do these statements if it's false. So then we won't have a null else. So this form of it has the null else. Okay, so I want to do the pseudocode for this, or do the code for this, the Python code. So the first requirement was, you guys read that okay? Other than the fact that it's gray because it's a comment. Get the score from the user. So the first thing I'm going to do is say score equals int input enter your score. Right, just like all the other assignments we've been doing up to this point. Get the total points. Okay, now we've got both of those. We can calculate the percentage. Okay, and so by now everybody should be familiar with, if I assign a score to this variable, it's going to be what data type? Integer. If I assign some total points possible to this one, it's going to be what data type? Integer. And percentage, what data type is it going to be? Is it integer? Because we got this little thing sitting here, this little divided by. It should be a float. Yeah, so this one could have decimals, right? Because the result of a divide by mathematical operation in Python returns a float always. So I could say this to be explicit about it, but I don't need to, because that's what, if I wanted to truncate it back to an integer, I could do this, but I don't necessarily want to do that, because if I do 85 divided by 100, I'm going to get 0.85 as my percentage value, right? And if I convert that into an integer, I'm always going to get 0. So I don't want to do that. Okay, so now I have my percentage, and I can say percentage is what did we learn we could do? We could do the little f here and put the name of our variable in here. Does that look right? Did I do that right? Okay, so if I run it, please enter your score, 85. How many points possible? 100. Your percentage is 0.85. That's not exactly correct, is it? Because as a percentage, it's supposed to be times 100. So, so if I just type times 100, is that going to work? Yeah, it will, but it sure doesn't look good if I'm a math person, right? If I was a math person, I'd probably feel a lot more warm and fuzzy if I put parentheses around that. Another thing that you'll see programmers do is they'll put the times in the front. That way you know it's 100 times the score divided by the total. And as an extra little bonus, if I did an int around this, now it will actually work because it's going to be 100 times 85. So I get 850, 8,500 divided by the total, which is also 100. So I go back to 85. So now my percentage is actually 85, and this will be an integer. So I'll try that. Your score, 85. Possible is 100. Your percentage is 85. Okay, that's not exactly what this said. It said to also repeat the score and the total points, but I have to do this in very large font, so I'm going to assume that you guys know that we can go ahead and do that if we wanted to. Now, if the percentage is at least 90%, then tell the user congratulations. So what that would look like is if it says if it's at least 90%, right? So what operator am I going to use here? Greater than. Greater than or equal to. Exactly. You got to be careful with that wording. If percentage is at least 90, then tell the user congratulations. So watch out for that in the assignments. It will try to trip you up like that. Yeah. That's what I typed in when I ran it. It's all right. It's not as good as 90. It's not as good as 100. Okay, so print. A nice little message there. Ah, if I try to run that, I get an error, don't I? And it's actually pretty self-explanatory too. Indentation error, expected an indented block after the if statement on line 9. Okay, fine. So now I've indented it. You know, if I put something here, so I think you guys get it. I don't have to pound this over your head, but you know, this line is not indented, so it will always print this line. but this line is indented. So it will only print that if it gets to this point in the program and the percentage is greater than equal to 90. Okay, I'll get rid of this. Okay, so this is where we talk about testing and test cases. Now that I've got a conditional statement in my program, now I need to use at least 2 test cases. I need to test what my program does when this conditional expression is true, and I need to test again when this conditional is false. So the first time I'll do just what I did before, 85, 100, and it says your percentage is 85. If I run it again, I say 95 out of 100. Now it says my extra print statement. Congratulations, you did great. Everybody get that? So I could give you like 5 different programming projects, and you could do all of these interesting programs, each one of them asking you to put an if statement in there. But I'm not going to. We'll probably just have one assignment that does a few of these different variations and leave it at that. So I can grade them all at once this time instead of having a bunch of different ones that I have to grade over and over and over. Okay. So on paper, it doesn't look that hard, right?
Right.
You know, it's just the if statement, a Boolean expression, a colon, and then you have to indent. How many lines do I have to indent? I did 2 here. If I do 4 or 6, is it still going to work? Yeah. It's kind of up to you. It doesn't try to be too overbearing about that. But, you know, I'll make it 2, keep it simple. Any questions about that? That variety? They'll get trickier, but this is the simplest one. You know, you just have something that you want to do only when some condition is present. Do you want me to do the flow chart right here or wait till the end and do several of them? Do the flow chart now?
I also need to know the science flow chart. It was probably like wrong, but
Okay. Well, probably wasn't 100% wrong. It's probably only 10% or 20% wrong, but I see what you're saying.
Because the program I submitted was like, I added way more to it, you know, just so I could expand my knowledge.
Yeah.
I didn't know how to do the full chart for that, so I just kept it as the assignment.
Gotcha. Okay, fair enough. All right, so we've got our code over here on the right. And flowchart over here on the left. So the first thing is we have an input. Well, I guess I have to declare my variables. Score, total, percentage. That looks like all of my variables. Okay, I'm going to add an input. See, it's really nice in Flowgorithm because it tells you input. I'm doing an input statement, so it says input. I don't have to remember which one is the parallelogram, you know. So enter a variable name score. Another input for total. Yeah, and so far all of this is stuff that you've been doing, right? Nothing new here. We've got a calculation step. So I have to do an assign box, percentage equals 100 times score divided by total. A print statement, we've done those before. I'll output the percentage. And now we get to this. We get to this if statement. So we get to introduce a new symbol, but luckily the little diamond, the little orange pink peachy looking diamond down here already has the word if in it. So that gives me a really good clue that the if statement, and boom, it throws all the stuff in there for me. Okay, so we have a null else. So we're going to do something if this if is true. So I got a couple of things I got to fill in here. First, I'm going to double click on this if box, and it wants to know what the condition is. Well, it's percentage, my variable, greater than or equal to 90. That's the expression I wanted to evaluate. So it puts it right there in the box for me. So it says, ask yourself that question. Is a percentage greater than or equal to 90? If that's true, then we just put a box over here. If it's false, if we want to do something when it's false, we put boxes over here. So all we want to do is we want to put this print statement when it's true. So I click on this line and I put an output, and I output, I think I have to put this in quotes. There we go. That wasn't too bad, was it? And then here's the key thing to remember on the flow chart is afterwards they join up again. So if I had that print statement the end over there like I typed before, you put that down here. You can keep going, do other stuff with your program. Let's see if that works or if I did something wrong. Okay, down here in the really teeny tiny print at the bottom, it says, please enter a value of type integer for score. So I'll type 85. Again, really tiny, apologize for that. It says, please enter a value of type integer for total. I'll do 100. So here's my output, my print statement. It says 85. So I'll have to run it again to do the other test case. Okay, please enter a value for score, 95. Please enter a value type integer for total, 100. And now I got my two print statements. I got the 95, which I wanted, and I got the congratulations because the percentage was greater than or equal to 90. Clear as mud. Okay, so now to turn this in, I think all you guys have been doing this correctly. We say save as, and the extension is FPRG already. So I type in my assignment, whatever you want it, and you save it as an FPRG and submit that. I think everybody's kind of got that. And then if you're using Thonny, it says untitled, but I would say file save as, and it's already got Python selected. So I would type, wherever I want to put it, documents, whatever, my assignment.py. Okay. Everybody good there? No questions at this point? Okay. Okay, so I shouldn't have closed that, but what if we want to encourage them even if they didn't get an A. So the difference here is going to be, we're not going to use a null else, right? So I've changed my pseudocode and I added this to it. So I said, if the percentage is at least 90, then tell the user congrats, like before. But I'm going to also say else, tell the user to keep trying. So now I'm not going to have a null else. I'm going to have something to do with the else. So like I said, I shouldn't have killed that, but I'm gonna cheat here. Score equals 85. Total equals 100. And I'm just gonna do, let's see, percentage equals 100, about int 100 times score divided by 100. All right. Okay, so that's basically where I was before, right? I said if percentage is greater than or equal to 90 colon indent print congratulations. And here's where I do the else. Keep trying. So pretty simple, just like before. You just have to put the else in here. And just like before, if I wanted to do something later, I could keep going with my program. I could do other things. Right. Yeah. Yep. We'll get to that in a moment. That's what we would call cascading ifs, or yeah. So we'll get to that variation. It's just another variation of the syntax. You're exactly on the right track. So on this one, I can do something if it's true, and something else if it's not true. You know, the opposite. So it's else. But let me see. Yeah, okay, that is the next slide. So let me just click forward to the next slide. So yeah, here I want to say, I just have a whole bunch of things here in my pseudocode. Again, this is a pseudocode. So if it's at least 90, tell them an A, you know, you get the point. Oh, I didn't change my scores here. Let me do some magic here. There we go. Yes. Yep. Yep. You could, yes. But I was just going to use that to illustrate. You caught it very well. But let's look at what that means in the syntax. Okay, so if their score is at least 90, I also want to tell them you got an A. So all I have to do in here is right. And all I'm showing you here is that all of the lines of code that are indented inside there, they all get executed if that conditional is true. That's the main thing I'm pointing out there. So, I hate to spoil the surprise if you're waiting to see something exciting there, but it's no more complicated than saying elif. Right? Elif means if that one wasn't true, then if this one's true, right? And I put more statements in here if I want. Yeah, and the colon doesn't go here, it goes out there, just like with the if statement. Yeah, I'll be nice and won't tell them they got an F. I'll just tell them that they need to keep trying. There, that looks better. And that's what we would call a cascading if structure. Yeah.
You have to put the elif in there?
Yes. Yeah, you have to put all of them in there. Yeah, like that. I mean, there's other forms if you're referring to some other form, but yeah, this is the general form of a cascading else if, else if, else if, else if. Now, oh, if you're saying, could I just do this? Yes, in this case, in this example, this does the same thing. Well, until you get down to here, right? Because down here, the else doesn't work anymore. The other thing is it's more efficient because if you said congratulations, do you really need to check to see any of these other questions? Do you need to ask any of these other questions? And that's a reason why we do the else if, because we don't want to ask all that, we don't want to execute all those other instructions. We only want to execute those instructions if this one was false, if greater than 90 was false. Then we want to say, was it greater than 80? False. Greater than 70? False. We want to cascade down through there. It's kind of like a big pachinko machine. The peculiar thing about this, though, is I'm testing the same variable, but for different values, right? And I'll talk about this later towards the end, but other languages have a specific way of doing this that is pretty clever because they got sick and tired of typing all of these letters. They wanted to do it more simply. And specifically the case where I have one variable and I want to test it against a variety of values, then we can use this thing called a switch statement in many languages. But Python doesn't have one of those, so we can't do it here. All right, so the flow chart. This is where it makes a difference to pay attention to the code you just wrote, because the flow chart will be different depending on what the form you took here is. I'm just going to drop down to the if statement part of it, because you guys know how to do this part already. We just did it. You just saw me do this. So I'm just going to do the cascading if thing. So obviously it starts with an if. Right? If it's true, I say, congratulations. And well, so the way I wrote the code, if I was being precise about it, I would have two output statements. All right, so that's what that would look like, with multiple statements inside this block of code. But since I don't have a null else, I have an additional thing to do when it's false. I'll click over here, and the thing that I have to put in there is another if statement. Right? So that's what that looks like. If that's true, I print. You got a B. If it's false, what do you think comes next? Another diamond, right? And you can kind of see the shape this has taken. That's why they call these cascading if statements. It really shows up when you're looking at the flow chart. Yep. If it's true, I have another print statement. It's a little bit repetitive. And one more. And then I get down here to the last else in the chain, and it's just a straight else. So could I have a null else? I could. I mean, if what I was programming, I didn't have an else, I just have if, elif, 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 I might not have an else, right? I don't have to. But in this case, I do. So in this case, I do something if it's true or false. So on the false side, I have, just like I did before, keep trying. Okay, so that's what it looks like. A set of cascading if statements. And now you're probably starting to see how if I have a really complicated program, the flow chart could get really big. You have lots more boxes on here. Another thing that hopefully I won't blow your mind here, but we obviously we're doing a lot of these things just to illustrate how you could do it, but there's a slightly more elegant way of doing this. Maybe, I don't know, maybe it's a style thing, but I could create another variable, right? I could say grade equals something, right? And then I could say, if the percentage is greater than 90, grade equals A. And then down below, I could just say, your grade is great, right? I think a lot of programmers would consider that a little bit more elegant way to do it. And then, I mean, you know, when you start saying, oh, I want to go a different direction, your program gets complicated because now I have to remember, oh yeah, this congratulations, that goes down here. I have to say if grade equals A, print congratulations, instead of checking the percentage. Right, so the structure is very similar. I'm just setting a variable, and it occurs to me when I look at a program like this, anytime you see repetition, you know, so I see this string, you got A, over and over and over again. So whenever I see something like that, I'm like, ooh, not elegant. Maybe there's a different way, right? So that's what, I guess to be precise, I would say you got and I mean, to me, this is one of those things where it's really important to realize this. It looks like a simple change, but it's really important to realize that this pattern, which is the state of these variables, as you're running your program, the state of the variables changes. So up here, the value of the variable grade is one thing. Then down here, it's another thing. Then down here, it's another thing, right? And, you know, your logic isn't static. You may have, when we get to repetition, you may be executing this loop multiple times. And every single time you go through this loop, the value in that variable changes to something different. So the output that you get, what your logic paths, you know, go through, is different depending on the value in those variables at that time in the program running. And that concept is really important to get. So when you start seeing things like this, where it's an opportunity to say, well, instead of just putting a print statement in there, set the value of a variable that I can test later to see what the value is. If you can get that pattern in your head, it will unlock a whole bunch of things later. And I'll go ahead and finish this off so you can see it. So it looks very similar, just a different way of doing the same thing. And in programming, that's often true. There's often many ways to skin a cat, and your style, your choices may be different than the person sitting next to you, and that's perfectly fine and encouraged. You know, be creative. You know, when people solve a crossword puzzle, some people start at the crosses, some people start at the downs, some people just jump in and randomly do them, whatever, as long as you all get to the same solution in the end. Does that make sense to you, what I did, how I changed it? Yeah. It would likewise change my flow chart, but it's a similar thing. You're just going through here, and instead of doing your print statements here, you've got your assignment statements inside here. And then your print statements go down to the end. Do you want me to see me modify the flow chart? Yeah. Okay. So the condition is the same. I don't have to change that. But instead of outputting congrats, delete, delete. It's an assignment. Grade equals A. Oops. Okay, so that's my nested if or my cascading if structure. And all I have accomplished from all of this code is I've simply set the grade to what the appropriate value is. So now when I get down here to the bottom, after this little bottom arrow here, that's where I want to put my print statement. What am I going to print? You got a, and I put the value of the variable. So very similar to what it was before. And then I could also put, these other if statements down here. Just keep going, keep building up your logic of your program. Any questions? Clear as mud? Okay, I'm not going to delete them this time until I remember which slide I put next. So yeah, linear nested if or cascading if is what that's called. So it's just terminology. Remember those terms. And the only reason why you would need it in regular practice is if your boss said, hey, I think this situation calls for a linear nested if structure. You'll say, oh yeah, I know exactly what you're talking about. Let me go grab my notes. Okay, so I'm modifying it again. I've already kind of touched on some of this. The nested if or the combined if is a little different. And then this part I've already illustrated with this. We can set the variable and evaluate it later. So I've already showed you that. That's what we just looked at, right? That's this. But this nested if, combined if, those are important. Well, the term nested, that's what we're doing here. When we say else if, we're nesting another if inside there. But this was, like I said, a special case where we have one variable name and we want to test it against multiple values. Okay. So that's specifically a cascading if or a linear nested if form. But there's another format for the nested if. I'm gonna see if I can't go back to what I had before with a whole bunch of undos. Yes. All right, so what a nested if would look like is if, and this is kind of a little bit too much of a simple example to illustrate this well, but bear with me. If I wanted to say congratulations, so the person, we already know that they got over 90%, right? But if they got a 90% and additionally, they got over a 95, I also want to say hey, you did a really good job on this. Since you're an honor student, put this in your portfolio. But how do I know if they're an honor student or not? So let's ask them. So we'll ask them, are you an honor student? Yes or no? Okay, so here's where the combined if comes in. And honor student equals yes. So I've said if this condition is true and this condition is true. And so that's when we get into all the different forms of what kind of expressions can we build up. We can make them really complicated. So just remember that that one's called a compound if because I've got multiple variables I'm testing for multiple values. I've got multiple conditions and they're joined together with ands or ors. So these are nested, but these are also nested and cascading. This one is nested, but it's not cascading because it's asking something different. And that's where, like I said, apologies, because in this case, it's asking the same thing, just a different value, 95. But if you see inside an indented section, you see another if statement, then that's a nested if. It just doesn't happen to be a cascading nested if or a linear nested if. And whenever you see and or and or in your expression, you know it's a compound if. Those are a lot easier to flow chart too, because in your flow chart, let's just do this one. All you have to do here is include it. Say and honor equals yes. You don't have to create another box for that. You can just say that's your expression. Okay, any questions about that? Like it says, if you're using and or, and or, then it's a combined if. I think I covered everything on this slide. Any questions? Did I mess anybody up? Did I blow you out of the water on that? Okay, I felt like I stumbled through that, so sorry. All right, so the not operator. I think I talked about this a few weeks ago, but I want to bring it up again. So I introduced it before. I'm going to talk about it again. Hopefully, if I talk about it a couple more times, it'll stick on the wall. But when we're using this not operator, you have to take some care. So is A equal to 5? The opposite of that is not A is equal to 5. Or you can use the operator exclamation point equals, and that also means not equal to. So not A is equal to 5 is the same as A is not equal to 5, which is opposite of A is equal to 5.
That's the initial point, and it's equal to 5.
Yes. Yeah, that also says A not equal to 5. I think. Am I lying to you? Is that Python? Because some languages say less than, greater than. Like I said, I deal with so many different languages, I always have to check myself. Does anybody not believe that that's not equal to in Python? Okay, well, I've at least got you guys fooled. But if you're trying it at home and you get a compiler error and it says, what the heck are you talking about? Then do less than, greater than. Okay, the next line, A is greater than 5, or I guess to be precise, is A greater than 5? This is a Boolean expression. It can only result in a true or false value, right? A is either greater than 5 or it's not greater than 5, true or false. So the opposite of that, not A is greater than 5, that would work. Or this is where it gets tricky. You have to add or remove the equal sign when you flip it around like that. When you use the not operator, not A is greater than 5, is A less than or equal to 5. Okay. And similarly on the greater than or equal to. Except that I didn't change this one. That's a typo. There. Yeah, so not A is greater than or equal to 5 is the same as A less than 5. Another typo. Copy and paste kills. Okay, I think I've got it that time. This is a really cool page. You know, I've talked about W3 Schools before, but if you go out there and you just read on Python conditions on W3 Schools, they've got a whole bunch of examples that are probably a lot more clear than the ones I did. Excellent. Yeah, the book's not bad either. I mean, the book's got good examples too. Okay, another example. So we're going to design an algorithm that's going to prompt the user for 3 characters, just 3 single characters. And we're going to get those via input statements like we have been, nothing fancy there. And then we're going to sort them into ascending order and output them to the screen. So I would say this is probably the most complicated problem that we've posed so far. You know, on the scale of where we are to Einstein, it's still pretty low on the scale. You should get to a point where things like this is like, oh yeah, that's easy. I understand if it's not right now, but it's doable. We should be able to do this. So my pseudocode is pretty simple. Get 3 characters from the user, sort the characters, and then output the sorted characters. Yeah.
How will we sort the characters?
Yeah, you picked up on that. And like my cartoon over here, I'm sure you've seen this in various forms all over the place. I came across several different cartoons that use the same joke, but they've got all this complicated logic, and then they've got a box here that says then a miracle happens and you get your output, right? So that's kind of like what we're doing here in our pseudocode. So I will pick up on that. I heard a story once of, you know, they had this this guy that was going for his PhD, and a bunch of people had been through this committee, you know, a number of times, and you know, they'd get these questions and they'd write all these pages and pages of math formulas and stuff, and put it through the committee, and they'd grill them and ask them questions about every little thing on every page. And finally, they had this one student that came through, and he looked at the problem and he just said, well, it's obvious, isn't it? And turned it into the committee. And the committee, they're like, well, okay, yeah, he probably does know how to do this, so they accepted it. But, you know, there's a difference there. When you know who you're talking to, you can trust them. So you at a certain point, when you say sort the characters, everybody will just say, well, yeah, obviously you can sort the characters there, and this is the place where you want to do it. But at this point, we're probably going to have to add a little bit more detail. Okay, so we got to identify the processing steps. Prompt for and get the 3 characters, and we're going to store them in variables. So all I did was I got a little bit more specific there, and I gave the variables names, right? It's still pseudocode. It's not Python, but it's a little bit more detailed. Then I'm going to somehow sort them so that CH first contains the lowest one, CH second contains the middle one, etc. Okay. CH third will contain the one that's the highest value, and then I display them. So not too much different from the first one, just a little bit more detail. So this one's even better. I'm saying display my prompt, get the character from the user and put it in the variable, display the next one, et cetera, et cetera, et cetera. But yet I still have this block down here that says some magic happens and they automatically get sorted. And then I output the 3 variables. So I'm saying you can get more and more detailed and more refined and kind of BS your way through it to a certain point. But at a certain point, the little magic happens box is still there. We got to figure that out. Okay, so now is where we have some puzzle solving to do. And you could probably guess that we're probably going to do this with if statements, right? And I'll just give this one to you. This is the logic we're going to use. If the first character is bigger than the second character, then swap them. If the second character is bigger than the third character, swap them. And then check again, the first 2 of them, swap them. And I mean, you can try a bunch of different combinations and test cases to prove to yourself that that's right. But at this point, just trust me, it works. If you do those 3 operations, no matter what 3 characters you enter, they'll be in the right order. And then you can just output them. We still got a little bit of magic though. How do we swap 2 variables? Okay, to swap 2 variables, we use a temporary third variable. So we move the contents of the first character into this temp variable. So temp equals first character. Then we say, move the second character into the first variable. So first variable equals second variable. And then we move the temp variable into the first variable. Okay. So that's a classic swap algorithm. If you program a lot, you will probably use that over and over and over again, that technique. So at this point, we should know all we need to do. And I want to make this point too, like I did before, with the more elegant version where we did the delayed gratification, set the variable and tested it later. Notice what we're doing here. We had the main problem. We've got more and more refined on our main problem, but we still had that sub problem to solve. So we solved the sub problem, which was how do I sort 3 variables? But even inside there, we had another sub problem, which was swapping 2 variables. And so then we solved that one. And that also is another example, another point that I want to get across to you is that if you get into this mode of just breaking things down into smaller and smaller and smaller problems, that's programming. Yeah, and later we can use functions. So you'll probably have a swap function at some point that tells you how to do this. And you can just call it instead of having to copy and paste the code. So here's the bestest pseudocode. So the top part there is displaying our prompts and getting our characters. So this is our input phase of our program, right? Then we have our processing phase. So here's our first one. Compare the first character to the second character, and if they're out of order, swap them. This is how we swap. Next, we do the second step, which is the second and third are out of order, swap them. Then if the first and second are out of order, we swap them. So if you do those three swaps, you're guaranteed to have those three variables in the right order. And then finally is our output phase of our program. So inputs, processing, outputs. And it's just a more complicated, longer version of the same programs we've been writing up to this point. I can't drive that home strongly enough that building up to these big, complicated looking programs from the small stuff that you already know how to do, don't get intimidated when you see some big, hairy, complex problem. Just break it down into stuff that you already know. And like I said, once you get sequence, selection, and repetition, you've got all the building blocks. There's no more mysteries. You could solve any programming problem with those three. So you're this close. We just got to get through the repetition part in a couple of weeks. Okay. Yeah, and this pseudocode is the bestest because we've refined it to a point where there's really no more detail to add without starting for it to look exactly like Python, which then it becomes our program, which is kind of what we're talking about, right? You start out with really vague, bluff type pseudocode. Yeah, don't worry, I know how to do that. Some magic happens here, and then it all, yeah, I have all my values that I can print. And then you keep refining it until it looks something like that. And then all of a sudden you hit the compile button and it works. Okay. I'm trying to think if there's value to me flowcharting that, because it's all it is assignment statements, input statements, output statements, and then the new if statement that we just added. That's not even a very complicated if statement, right? Do I need to flowchart this one? Okay. So to all you people online, they didn't want to see it flowchart. So. Okay, next one, I mentioned this case statement. So I wanted to point out what that looks like. Just so you have it. Come on. Yeah, I figured I'd show you from C#. Come on, show me a good one. They want to show me. Okay, here we go. Finally. So here's an example of what a switch statement looks like in C#. So again, this is a special case of the nested if statement. Specifically, it's a case where we would refer to it as a linear nested if or a cascading nested if structure, which means that I've got one variable, in this case it's I, and I'm comparing it to a bunch of different values, same variable, different values. And so this is what a switch statement would look like in C++ or Java or C#. They just say switch on the variable name or the condition. You know, it could be an expression, I times 40, whatever, but it's switch on that expression. And whatever that expression evaluates to, compare it. Is it a 0? If it's a 0, do all this. If it's a 1, do all this. If it's else, So they say default instead of else. If it's not any of these values, then do this. So it's pretty much the same thing. They just make some pretty syntax to make it look cleaner without so much repetition, without all those, without repeating I. Because you could have said, if I equals 0, do this, else if I equals 1, do this, else do this, but this is prettier. Except for the break statements. Having those repeated break statements in there is annoying. But the reason why that's in there is if I omitted this break statement, it would run this case 0 and then just fall into the case 1. So it would do both. Sometimes that's what you want it to do. But whenever you hit the break statement in a switch, you go down here and fall out the bottom. So there you go. We don't have those in Python, but if you ever see them in your next class, whatever language that is, then you'll know what they're talking about. And then I wanted to throw something extra in there. Has anybody heard of this, IFTTT? It's an acronym for if this, then that, is what it stands for. But it's this website. You can go to ifttt.com, and it's evolved a lot since I had fun playing with it a few years ago. But it's this big website where, so like on the internet, there are events that happen. And when I say events, I mean like you received an email. So your email server says, I received an email. And it sends out an event to itself, to the other code inside the email server. It says, yeah, a new email has arrived. Well, if you create an account on IFTTT and you hook IFTTT into your email account, you can say, if I get an email that fits this criteria, do this. And the do this could be a whole bunch of stuff. It could be start your Roomba vacuum cleaner. It could be send me a text message. It could be all kinds of stuff. So they have all these integrations on the event side of things, and they have all these integrations on what you can do if that event happens side. And you can sit there to your heart's content and wire all these things up and just basically automate your life, automate things that happen around you. One of them was you can set it up to where if your phone receives a text message, of course, this requires, like for me, I would have to install the Android app of IFTTT. But if I install that and I set it up, I can say, if I get a text message with the text lost phone, then turn the volume up. How helpful would that be, right? You can't find your phone, but dang it, I set it on do not disturb. So I can't hear it if I call myself. I can't hear it ringing. Well, you can send yourself a text message that says lost phone or whatever you tell it to be. And if you get that text message, IFTTT will then call the function on your phone that says turn the volume up. Pretty cool, huh? All right, so now that we've talked about all the selection, these conditionals, I thought IFTTT would be a cool thing to talk about, because it's just, if this happens in the world, do this, right? You can have all kinds of fun with it. Yeah, there you go. Any questions? That was all I had for tonight. I don't have an assignment up right now, but there'll probably be one up soon. That's obviously going to be something related to conditionals, and I hope it's fun. I probably, since it's not up there tonight, I probably won't make it due Tuesday. I'll probably make it due the following Tuesday, so you'll have an extra week to play around with it. So anyway,
Were you marking it down as well?
I
Or you didn't do it? I was able to turn that in, by the way. I renamed it and put